So hello everyone, this is lecture 8 for thermal physics. In the last lecture we were discussing about the mean free path, and there were two methods to find that. First was zeroth order and the second is first order approximation. So we already studied the zeroth order. So today we will study the mean free path in first order approximation. So in the zeroth order we considered that only the particle considered is moving, others are at rest. But here we will take the relative motion because all the particles are moving. So if there are any two particles, then the speed of the first one with this is relative to 2 will be v1 minus v2. So we will take this speed this time, means we will consider all are moving. So if the square of this will be v1 square plus v2 square minus 2 1 v2 v1 dot v2. Now see, if we take the average of this quantity, then this average of this will be 0, because this will give you cos theta and theta between that will be random, and the sum of all the cos theta will be 0. So these were the approximations they take, I mean the physicist at that time. So this must be 0. So now, and we approximate some average value of all the particles, that is v. So v1 will be v and v2 will be v. So it will be 2v square. So vr square is nothing but 2v square. But see, to find the mean free path, the formula were, this was your formula, average speed multiply the tau. So we need average speed, but here we are having the square average, means s square means average of a square. So we need to convert this into the form of v. So how can we do that now? See, to calculate mean free path lambda we require vr and not the vr square. So we approximated vr. Now we will see this approximation, means the this v square average can be written as v. So this is v average and this is nothing but this is root mean square. So see, we are just equating both of them. So let's see what error can we find it here. So let's find the ratio of this and see the value. So this is the average speed. Average speed is nothing but under root 8 kt by m, and this is RMS speed, that is 3 kt by m under root. Now see, if we cancel the terms, then it will be under root 8 by 3 pi. So this number will be 0.92. Now means there are error of 8% because this is 92% of this. So 8% of error is acceptable. They accepted this value. So we can approximate this with this. Okay, means under root v square average is equal to average of v. So we need to find the vr. So we'll assume it under root of vr square. So this must be equal to this. Now vr square is equal to 2v square. Now it will be under root 2 this. And now this must be equal to this again. So this value will be equal to under root 2 v average. Now all these approximations are done on the basis of this, that v square average under root will be equal to v average. So we assume that here also and here also, and then in the last we get the average speed as under root 2v. Okay, now we can just substitute this value in the formula to find the mean free path. Now lambda will be v tau. So v multiply 1 upon n sigma vr. So this vr is nothing but under root 2v. So in place of this we'll write under root 2v. We will cancel out, so we will get 1 upon under root 2 n sigma. This is your mean free path, and this is the more correct value as in the zeroth order. So you must remember this result. If it is not given that it is zeroth order, then you must use this result for to find the mean free path. Lambda will be in the form of the, if it is for the ideal case, you can write kBt divided by under root 2 p sigma, where p is pressure, t is temperature, kb is Boltzmann constant, and sigma is pi d square, that is area of influence, cross section area of collision. So you must remember these formulas. This is the mean free path in the first order approximation. Now there is one more thing remaining in this, that is survival equation. What is survival equation? Means there are large number of particles, they are moving, and with time they are colliding. Means initially all the particles are with no collision, but with the time the particles are decreasing. Means those who have collided and those who have not collided. So the not collided particles are decreasing. So that is the equation for the not collided particles. Not colliding means at up to what time they can survive. So suppose we have large number of gas molecules, as they move, they will collide. What is our objective? To find the number of that have not made a collision, that is survived for some time t. So up to time t, what number of particles or fraction of particles survived without any collision? That is our objective to find. Let number of molecules be n naught. So initially total particles is n naught, and they are the total with no collision. Now let number of molecules surviving a collision after traveling a distance x. So after traveling a distance x, let's say there are n particles which survived without any collisions. So fraction will be n by n naught. So if each molecule is allowed to travel further a distance dx, more collision will take place. Now after x, if they travel dx distance, then there will be more collision, and that collision will be proportional to what number of particles were remaining, and at what distance they are traveling. More distance they will travel, more collision will take place, and more number of particles there, more collision will take place. So with dx will be proportional, means number of collision, that is dn we are representing after the x, that will be proportional to the number of particles present and the distance traveled. So if dn be the number of molecules which suffer collisions while traveling a distance dx, that will be proportional to n and dx. Now here we can just remove the proportionality sign with the proportionality constant, that is minus pc and dx. So we assume this because the means this value is reducing with collision, means number of particles remaining to collide is decreasing, because with time all particles are colliding. In the last there will be zero particle without any collision. So that's how, means you will see that curve will be exponentially decreasing. So that's why we take it negative here. Now let's solve this equation. Just take this n this side and integrate. It will give you log n equal to minus pcx and log some constant c. Then n will be c exponential minus pcx. This is the n number of particles which are not collided up to the x distance. So there we have two constants, that is c and pc. We need to find these values. Now at x equal to 0, there will be all the particles equal to n naught, which is not collided. So at x equal to 0, this will be c will be n naught. So now number of molecules at x equal to 0 will be n naught. So this is your equation. Now see, still pc is some constant, or means you don't know the value of this. So you need to find this constant. That molecules which survive a collision decrease exponentially. Now see, these n represent the number of particles or the molecules survived. Now as x is increasing, then this exponential, this whole value is decreasing. That's why the number of particles surviving the collision is decreasing exponentially. Now probability that molecules will travel a distance x without collision is, so probability will be the number of particles surviving divided by the total number of particles. So that will be n by n naught is equal to exponential minus pcx. So this will be your probability of surviving, means this is the fraction of particles or the probability of the particles which are surviving the collision. And now see, this is the probability we can check. We can just integrate for the complete x. That must be equal to 1. So if you integrate this, it will be exponential minus pcx divided by minus pcx minus pc. So if you just put the limits, this will give you 1. So you can check this. So it was pc multiplied this will give you 1. Okay. Now we need to find this value of pc. So how can we find the pc? So to evaluate pc, we evaluate lambda, that is mean free path. So what is mean free path? If you have the probability, so you can find the mean free path also. So that will be, means in the dn was the time, means it was not time, dn was the particles which suffer the collision in the dx distance. So in the dx distance, dn particles suffer the collision, so they traveled some distance, so average of that distance is called the mean free path. So now we know how to find the average. Average is nothing but all the particles traveled between that path in the dx, that will be, and the x multiply that particles will, and divide by the total number of particles will give you average lambda, means average path traveled, and that is your lambda. So we already know this, that how to find this. So and this is nothing but, this is just probability multiplied by the x. So it will be, in place of x, it will be as it is. In place of dn, the mod of dn will be pc and dx. So we'll substitute here, and now we will just solve it. This complete dn will give you n naught, and n naught will cancel out, and pc will be taken outside. This exponential x exponential minus pcx will integrate it for 0 to infinity, and now this complete integral will give you 1 upon pc. So and this is equal to lambda. So from here we can find that pc equal to 1 upon lambda. So pc is nothing but 1 upon lambda. So just substitute it here in this equation, n equal to n naught exponential minus 1 upon, means x upon lambda. So this will be your equation, and this is called the survival equation. You must remember this. Okay, so what this equation represent, that x, as x increases, this way the number of particles decreasing without any collisions, means surviving particles are decreasing this way. Means at x equal to lambda, there will be n naught exponential minus 1. That number of particles will be remaining. Means if we plot x upon lambda here, and means fraction of particles here, probability function, so it will be at x equal to lambda, this will be 1, and the probability, means the fractions of particle decrease to 0.37, and the maximum value is 1, because n is n naught will be 1 here. And as this, it can be 2 lambda, 3 lambda also, distance can increase, and same, the value will decrease here. So it will go to 0, and this is how the number of particles surviving decreasing. Okay, so in the last there will be 0 particles without any collision. So this equation is known as the survival equation. Now there can be question framed from here. Fraction of molecules having mean free path between lambda 1 and lambda 2. Now see, up to this point, this shows that how many particles survived without any collision, and this point shows that up to this lambda 2 distance, how much particles survive without collision. So in between, the particles or the fraction of particles are those which collided. Means, let's say here we have n, here become it is n2. Means here is n1, it becomes n2. So n1 minus n2 will give you those particles which collided in between this range, lambda 1 and lambda 2. So if you need to find the number of particles collided between this lambda and lambda 2, means mean free path, then you will just do that fx1 minus fx2 will give you total number of particles that collided in between this range and have the mean free path between this range. So that's how you can do this, and this will give you a fraction of particles which collided between this range. And this is nothing but, from the equation you can say fx is equal to exponential minus lambda 1 by lambda minus exponential minus lambda 2 by lambda, because for fx1 that will be equal to exponential minus lambda 1 by lambda, and for fx2 it will be exponential minus lambda 2 by lambda. So we have subtracted this, fx2 minus fx1, this will be greater, this will be lesser. So this will give you the fraction of particles which collided between this range and have the mean free path between this range, lambda 1 and lambda 2. So you must remember this. Now let's see some questions. There are a very small number of questions asked from this portion, but you must know whatever the question can be asked. So diameter of N2 is 0.37, diameter is given. Calculate the mean free path for N2 gas at room temperature and atmospheric pressure. So room temperature means 300 Kelvin, that is 27 degrees Celsius. And atmospheric pressure is nothing but 1 bar, or sorry 1 atm, and 1 atm is approximately 10 to the power 5 Pascal, that is Newton meter square per meter square. So mean free path can be written for the ideal gas in this form, kBT by under root 2 rho sigma. Now see, you don't know this n, that's why you need to write it in this form. For the ideal gas, you can write pressure and temperature and kb and sigma. Kb you know, this is this, and pressure is 10 to the 5, T is 300, and sigma is pi d square. D is already given, so you can find the value for lambda. Now 1 mole of an ideal gas with average molecular speed V0 is kept in a container of fixed volume. If the temperature of the gas is increased such that the average speed gets double, then lambda will be. So we need to find the lambda if volume is constant and temperature is increasing, then how it will affect. So see, lambda is kBT divided by under root 2 P sigma for the ideal gas. Now as this is the relation we know, so from here P will be nRT by V. Now V is constant, so only variables here are P and T. So substitute in place of P this value. So this T will cancel out and you will get lambda in this way. And V is constant, so this complete value will remain constant. So there will be no change in lambda. There is one more question. Two boxes A and B contain an equal number of molecules of the same gas. If the volumes are V and VB and lambda B denotes their respective mean free path, we need to find which one is correct. So see, there are two boxes and number of molecules are same. So lambda is nothing but 1 upon root 2 n sigma, and n is nothing but number density and n total number of particles per unit volume. So for the first box it will be lambda equal to Va by lambda 2 Na. Now this n is remain same because total number of particles is same, but volume is difference. So lambda will be this and lambda V will be Vb by under root 2 n sigma. Now just take the ratio, this will cancel out, you will get this. So this B part will be correct. Now in any question, if they say that air molecules are there and they don't given you specifically that this gas is there, then you will consider the N2 gas, nitrogen there, because in the atmosphere this is the most founded gas or the abundant gas there. Now there is one more question. In a sample of 10 to the 26 gas molecules, each molecule is moving with the same speed. Calculate the fraction of molecules that will continue to travel undeflected after traversing distance of lambda 2 lambda 5 lambda 10 lambda. So number of particles traveling undeflected will be given by the survival equation. This will be your survival equation. So n equal to this, at x equal to lambda it will be exponential minus 1, at 2 lambda it will be exponential 2 lambda by lambda will give you minus 2. So when x by lambda is 1, so means fraction of particles which are surviving over the without and undeflection will be exponential minus 1, exponential minus 2, exponential minus 5, and that's how you can find this value that will give you some number here also, here also, here also. So that's how you can use the survival equation to find the particles which are moving undeflected. Okay, so that's all. Here are the transport phenomena is ended. In the next lecture we will start some new topic. So thank you everyone.